Have you ever noticed that AI speaks with the confidence of a PhD, even when it's completely making things up? It doesn't just make mistakes, it hallucinates with total certainty. And in fields like healthcare, law, or finance, that certainty can be dangerous. Today, we're looking at why AI is an accidental liar. We'll dive into the fundamental flaws in how models are trained, and how we've inadvertently taught them to guess instead of admitting when they're unsure. But there is a breakthrough. We're exploring a game-changing solution from MIT called RLCR, Reinforcement Learning from Confidence Representation. It's the key to moving beyond blindly confident machines toward AI that actually knows its own limits. Let's dive in.
Welcome to The Explainer. Okay, let's just dive right into this, because today we're unraveling a pretty fascinating mystery right at the bleeding edge of artificial intelligence. If you've spent, any time using today's brilliant AI reasoning models, you've probably noticed a really specific, kind of maddening personality trait. They act exactly like the loudest, most overconfident voices in the room. They'll give you a beautifully articulated answer to a really complex problem, but they'll also spit out total nonsense with the exact same level of unshakable certainty. So today we're going to break down exactly why that happens, and more importantly, how researchers are finally teaching these models to do something incredibly human, to simply say, I'm not sure.
So let's start right here. Why do AI models lie with such unshakable confidence? We've all been there, right? You ask an AI a question, and it gives you an answer that sounds so authoritative, so totally, completely certain that you just believe it, right up until you realize it's completely fabricated. It's super frustrating. It makes you feel like you can't trust the tool at all. But as we'll see, this isn't some malicious intent on the AI's part. And it's actually not just a weird quirk of the technology that we have to put up with. It's actually a deeply ingrained behavior that comes from exactly how they're built.
Which brings us to a quote that perfectly hits the nail on the head. This comes from researchers at MIT's Computer Science and Artificial Intelligence Laboratory, or CSAIL. They said, "Confidence is persuasive. In artificial intelligence systems, it is often misleading." I love that, because the illusion of machine certainty is really just that, an illusion, and we desperately need to decode it. Because, well, when a machine sounds completely certain, human psychology naturally leans toward trusting it. We just assume that level of confidence has to be backed up by hard facts.
So, let's look at the overconfident AI problem and the real danger of absolute certainty.
We really need to establish right away that we're not just talking about an AI confidently getting a trivia question wrong. The real-world stakes here are getting absolutely massive. In high-stakes deployments, think medicine, law, finance, an AI's output can literally drive critical human decisions. So imagine a model saying it is 95% sure about a medical diagnosis or a legal precedent, but it's actually only right half the time. That is incredibly dangerous. In fact, it's way more dangerous than a model that just simply gets the answer wrong. Why? Because when the AI expresses supreme confidence, regardless of its actual certainty, we as users get absolutely no signal to pause and seek a second opinion. The system becomes completely unreliable in a way that's basically impossible to detect from the outside.
Which brings us to the flaw in the training. How did we accidentally teach AI to lie?
Let's play detective for a minute. How did these models get so arrogant in the first place? Well, researchers trace the root cause back to standard reinforcement learning. Now, this is the exact same method behind major breakthroughs like OpenAI's o1. Under standard training, models are rewarded for getting the right answer and they're penalized for getting it wrong. Simple, right? But that's it. There's nothing in between. Think about the difference between careful reasoning and lucky guessing. On one side, you have a model that arrives at the correct answer through careful step-by-step reasoning. On the other side, you have a model that just happens to guess correctly by pure chance, literally like flipping a coin. In standard training, both of these scenarios receive the exact same reward. Over time, the model figures out that as long as it throws an answer out there, it might get the prize.
Which leads to this really brilliant insight from Mehul Damani. He's an MIT PhD student and a co-lead author of the research we're digging into. He says, "The standard training approach is simple and powerful, but it gives the model no incentive to express uncertainty or say, I don't know. So the model naturally learns to guess when it is unsure." And honestly, that's incredibly logical when you really think about it. If there is literally no reward for admitting doubt and a potential reward for randomly guessing right, the AI simply learns to fake confidence all the time.
So, how do we fix this? Let's talk about teaching AI to doubt by introducing MIT's RLCR fix.
Enter RLCR. This stands for Reinforcement Learning with Calibrated Rewards. Think of this as the ultimate antidote to AI arrogance. Instead of just demanding an answer, this technique forces the model to actually stop and think about its own uncertainty. It trains the language model to not just spit out a response, but to simultaneously produce a transparent, calibrated confidence estimate. Basically, a score that accurately reflects how sure it really is.
And the secret ingredient making this whole RLCR thing work is something called the Breyer score. By adding this one single measure to the reward function, the researchers completely balance the scales. The Breyer score penalizes the gap between a model's stated confidence and its actual accuracy, meaning the model gets actively penalized for being confidently wrong. But, and this is the beautiful part, it also gets penalized for being unnecessarily uncertain about a correct answer. It basically forces the model to align its confidence perfectly with reality.
Let's just walk through this new 3-step RLCR process real quick. Step 1, the model reasons about the problem. Step 2, the model actively estimates its own uncertainty. And Step 3, the model is rewarded for its accuracy and its calibrated certainty, together. It basically learns to output an answer and a confidence estimate as a package deal. And the MIT team didn't just cross their fingers and hope this would work. They formally, mathematically proved that this specific reward structure guarantees models that are both accurate and well-calibrated. Now let's look at the real-world results and see what happened when they put RLCR to the test.
The MIT team applied this technique to a massive 7 billion parameter model across various benchmarks, including 6 data sets the model had never even seen before. And the results? Honestly, staggering. Just look at this number, 90%. RLCR reduced calibration error by up to 90%. Let that sink in for a second. It almost entirely wiped out the gap between how confident the AI felt and how accurate it actually was. And the absolute best part? It achieved this huge improvement in reliability while completely maintaining, or in some cases even improving, its overall accuracy. There was absolutely zero trade-off.
When you see the data side by side, the contrast is night and day. With standard RL, the training actually decreases calibration. It literally makes the model worse at estimating its own uncertainty. But RLCR completely reverses that negative effect, drastically improving calibration. And the data even shows that RLCR blew older methods right out of the water. You know, those older methods where developers tried to just slap a separate confidence scoring tool onto a model after the fact. This built-in approach is just so much better.
So, we arrive at why certainty matters and the true value of self-reflection. Because it turns out, aside from just giving us a number we can actually trust, the simple act of a model explicitly reasoning about what it does and doesn't know gives us real, useful information that boosts the entire system's overall performance. Isha Puri, another MIT PhD student and co-lead author, summarizes this urgency perfectly. She says ordinary RL training doesn't just fail to help calibration, it actively hurts it. The models become more capable and more overconfident at the same time. That is a wild thought, right? It really drives home the fact that we can't ignore this. If we stick to the old training methods, the smarter our AI models get, the more dangerously overconfident they're going to become.
Which leaves us with this final, provocative thought for today's explainer. If an AI can't bring itself to say, "I'm not sure," should you really trust it when it confidently says, "I know"? Next time you use one of these models for an important task, definitely keep that in mind. Thanks so much for joining me for this explainer, and I really hope this helps you navigate our increasingly AI-driven world with just a little more healthy skepticism.